Hello, everyone. My name is Tomotaka Wada from Kansai University in Japan. I'd like to talk about new evacuation guidance using augmented reality for emergency rescue evacuation support system, ERESS. At first, I'll explain the background. In recent years, sudden disasters such as fires and terrorism have occurred in the buildings. In the fire environment, it's difficult to obtain real-time disaster information from the fire outbreaks. We find the fire disaster after several minutes later. In a terrorism situation, the bank or other places have occurred in a terrorist in an emergency state. So we have to obtain the real-time disaster information quickly. We have proposed an emergency rescue evacuation support system, ERESS. This ERESS's purpose is the reduction of casualties by notifying real-time disaster information to evacuees. That feature is disaster detection and evacuation guidance are possible in real time. Each terminal communicates with each other and exchange and shares information, composing the mobile ad hoc network. ERESS can operate in any environment without depending on communication infrastructure. So the ERESS configures a manage. ERESS function is inputted in a smart home like this. ERESS is configured 5 functions as follows. First one is sharing information in Manet. In Manet, the terminal communicates with each other mobile ad hoc network to sharing the information of the smartphone. The second is the behavior analysis of terminal holder from the smartphone sensors, such as accelerometer, diameter, and angular velocity. The third one is disaster outbreak detection. From gathering the information from the neighboring smartphones, terminals, data, the disaster outbreak is detected. In this 1, 2, 3 function is repeated in a normal state, and in the disaster outbreak is detected, the 4 and 5 function start to working. 4 function is evacuation route search for the appropriate evacuation route to the exit. And after that, the 5 display route guidance in a smart home like this. The map is inputted in the smart home and display and guide the appropriate route. We have proposed a conventional method of the evacuation guidance by using the iBeacon. The guidance for evacuees to evacuate safely and quickly. This method's feature is using of iBeacon's area information. That is, iBeacon is attached on the ceiling. Multiple iBeacons attached on the ceiling so that they do not interfere with each other. So the terminal receives the transmission of area information and the terminal recognizes the area position. The process is as follows. Step 1 is each ERESS terminal obtains iBeacon's area information. Step 2 is the start evacuation guidance based on received iBeacon's area information. The terminal is near the iBeacon. The received signal strength RSSI is larger than the others. The problem with the conventional method is mainly the 2 problems. First one is poor visibility makes it too difficult to know the direction to go. In a fire disaster, the smoke will cause poor visibility. The second is not everyone can read the map correctly. So that people will be confused, go to straight, right, or left. So there is a need for a quick evacuation guidance method, even in situations with poor visibility or in places where there is no sense of ground. So we propose AR evacuation guidance using augmented reality technology. That proposed method's purpose is to reduce evacuation time even with poor visibility. And even tourists who do not know the land or people who cannot read the map can evacuate in an easy to understand and accurate manner. The feature is we can get directions from magnetic and accelerometers in a terminal. And we use iBeacon to acquire indoor position in the same manner in the conventional system. The process is the 3 steps. Step 1 is the direction is detected by magnetic sensor and accelerometer. And step 2 is each ERESS terminal obtains near iBeacon's area information. Step 3 is start evacuation guidance by displaying a 3D model suitable for each area. This is the flowchart of this proposed system. Obtain the current area from iBeacon and display appropriate 3D model in the current area. And mobile terminal moves the new area, the destination decision is made. And area change permission is made, change the new area to the current area. So this process is repeated. To verify the effectiveness of the conventional system, the proposed system, we carried out performance evaluation by experiments. The purpose is to verify the possibility of evacuation intuitively and accurately with AR guidance. Experiment environment is as follows. Experiment place is the 3rd and 4th floor in the building. Number of subjects is 6. We use the ERESS terminal as iPhone 6X. Display 3D models example is as follows. The arrow, right or left, shows the arrows. This is the experiment floor, 3rd and 4th floor. Start position is F44 room, and go out to and go straight in a path and go down and to the downstairs and go straight out of this building. Example of this space in application. This is a room, in a room, and go straight and open the door and display the right direction and go straight and can you see the door in the right? If it's so, the this screen shows next and go down the stairs. After going downstairs, this AR display is recovered and go straight line and go straight to the exit. When the red circle button is pressed, switch to the next display. From A to H, warning sound when switching the display. E and F is a camera display. It stops because he is on the stairs. Percentage of problems is as follows. Point A to F. Almost no problem, but the point C and E, it has some problems. In point C, in this situation, from the point A to C, in a C place, this display is showed in a smart home. So in this situation is good for to follow, but in this situation, in this position, in the right direction is elevator, so it was somewhat confused. And in a point E, the downstairs and go straight opens the door, and in this position, it's good, and go straight to the path. But in this area is a large space in a lounge, so the subjects go on to some walking. It will be show the go straight, face wall, so it has to be confused. And this result shown in the stopping and evacuation time from the subject 1 to 6. Stopping time is like this. The subject 3 is 6 times stopping. And total evacuation time from the start point to the end point, exit, is like this. The subject 2 and 3 is have more evacuation time than the others, but all subjects can evacuate quickly and accurately. Result of questionnaire is as follows. You could feel relieved if you have this address indoors without knowing the building. Strongly agree and agree is configured. And you could get the goal without thinking by only following the displayed guidance. Strongly agree and agree is mainly shared. And third one is you sometimes felt this application difficult to operate. Disagree, strong agree is shared. So it's effective to use. It's not difficult to operate. There are some points where you are confused. Agree and disagree is the same numbers, because the AR showing is a little delay in the actual position, so it has caused a confused situation. Conclusion, we have proposed AR evacuation guidance using augmented reality technology. We have confirmed the effectiveness of the proposed method based on the result of the experiments. Thank you for listening.